Hello, I'm Eric Snodgrass, Senior Science Fellow at Nutrient Ag Solutions, and I thought I'd take some time today on World Food Day to kind of talk to you about how weather plays a critical role in one of the world's largest bread baskets. I'm talking about the Mississippi Basin in the United States. So to do that, I want to take you back and give you a little history as it relates to weather. Take a look at this first animation. What you're looking at here could be any given day across the North Atlantic. You've got this large area of high atmospheric pressure that sits in here. We call it the subtropical high. Now, around every high pressure center in the northern hemisphere, the flow always goes clockwise like this. And what's important about this flow is that it was integral to the exploration of what was once called the New World. I'm talking about North America and South America. You see, the old world was Europe and Africa and parts of Asia. And when explorers wanted to go out across the open Atlantic, they would leave Europe, follow the coast along Spain and Portugal down here to the coast of Africa, the west coast of Africa. Now, a lot of people and goods were picked up there, and the ships, these merchant ships they were using to explore the world, had their sails filled by these winds right in through here. They're called the trade winds. They got their name because they fueled trade in the 14 and 15 and 1600s. And those ships were brought across the open ocean. They came to South America. They came to what was once called the West Indies. These are these islands in through here. And eventually these winds carried their ships up to what was then known as the New World, now North America, or the United States. Now, the winds were interesting because once you get around the northern side of this high pressure cell, those winds would then carry them back. The westerlies would take them back to Europe and completed this huge trade route. Now, just thinking about that, the winds, okay, I want to give you two perspectives on this. How did those winds govern how people from this part of the world end up moving to this part of the world? And secondly, what's going on here that makes this such a massive breadbasket? So let's talk about those two things. My next picture is just kind of a topographical map of the United States. And remember, when people began to arrive from Europe and Africa on the east coast of now United States, they settled into this area. What I just outlined for you is the original 13 colonies. Kind of the western border was mostly here, the Appalachian Mountains, and on the south side, we wanted Florida, but the Spanish wouldn't let us have it. Now, there was a problem here in that as we began to populate these 13 original colonies, there was this massive push to want to go to the west. But the British did not want us to go to the west because to go to the west meant it was going to be more and more difficult to tax us. So we kind of just said, well, forget you, and we wrote a letter to them. We called it the Declaration of Independence. We went west anyway, and what we discovered was called the Northwest Territories. It included states like Illinois and Indiana and Ohio and Wisconsin, and Michigan and Wisconsin, and these states comprise some of the best agricultural land that we've ever seen around the world. But on our western edge of the Northwest Territories, as it was once called, was this massive river system. And that massive river system had some of the most fertile farm ground that we've ever seen in the world along it. And we wanted it. We wanted both sides of that river. And so who owned the other side? Well, it was the French that owned the other side of this. And we thought we'd have to go to war with the French to get it. Turns out all they wanted was a $15 million check. And in 1803, the United States bought the Louisiana Purchase and basically doubled the size of its land area. Now, I'll stop there and not continue to tell you the story of the rest because what we just purchased here, explored and purchased, basically was one of the largest systems of fresh water moving across a continent anywhere in the world. And where did it flow to? The crown jewel of all of it down here into New Orleans. And that particular port flows into an unfrozen body of water called the Gulf of Mexico, from which massive trade would stem from the early time period in U.S. history. Now, if you're curious, this is what the Mississippi drainage basin looks like. It drains over 40% of the land area in the lower 48. And as this map kind of slowly fills in here, I want to give you one interesting thing to think about. The river system that you see right here contains the largest network of flat navigable water space anywhere on Earth. Now, I'm talking about river systems, not the ocean, of course, but flat, navigable, fresh water. That's it. You just saw it populating right there before your eyes. What makes it so unique is geography. And it's the fact that when you look globally, the only really long mountain chain that runs north-south would be the Rockies and the Andes. Everywhere else on the planet, most of the mountain chains run west to east, right? So what advantage does that give this particular breadbasket? Because it's in the middle of a large continent. You would actually think it'd be dry, like the central part of Asia, but it's not. because to the south, down here in the Gulf of Mexico, there is no physical barrier preventing all of the warm, moist, and unstable air here from moving into the midsection of the United States. So geography plays a key role in giving us adequate precipitation to grow the crops that line that Mississippi Basin. And that includes the Ohio River, it includes the Missouri River, and all of those other tributaries. But just notice, this annual precipitation map shows that across some of the most fertile ground on Earth, there is generally speaking enough water to do dry land farming. Now that's the setup. Occasionally, though, there's drought on this area. And we think about this because of global food security. We think about this in terms of global food production, food, feed, fiber, and fuel. All of it comes from this breadbasket right here in the central part of the United States, and it contributes to this big global cycle of those things in the production and the buying and selling of it. It's a global trade. Well, this year, I want to show you what happened. When you look at this next map, it is looking from a time period of May the 9th to June the 28th, and inside of every climate reporting district, there's a number. That number represents a rank. We have 130 years of reliable weather data across the United States, and the closer you are to 131, that'd be the driest, 1 would be the wettest. Now look what happened this spring of this year. We saw massive droughts settle in on the Ohio, parts of the Missouri, and most of the upper Mississippi and mid-Mississippi Basin. It flooded down south, it flooded along the Rocky Mountains, but right here in between, we just lost all of the moisture in that particular area. And I want to put this whole story together to tell you why, because this had a massive impact on the farmers right here in the midsection of the country. In fact, right about where I live over in Champaign, but the climate district next to me, this one right here that covers parts of central and western Illinois, driest on record from May the 9th to June the 28th. Well, this is what happened. When you look historically and stack up every year from 1970 to 2022, we find these two big high-pressure cells that flank North America. You've already learned about the Bermuda High. Now, we care so much about these semi-permanent high-pressure cells because of the way they get the air to flow. And normally when the Bermuda High is there, look what it does. There's the westerlies on the northern side. Here's the flow that comes down from Portugal to Africa. It moves across the open Atlantic, and look, it goes into the Caribbean, into the Gulf, and right here pulls all of the moisture right out of the Gulf and right into that breadbasket, the Mississippi River, which then drains the moisture back into the ocean to be recycled. Okay, every major episode of drought, listen carefully, every major episode of drought in the Mississippi Basin has come as a result of the Bermuda High not being between Bermuda and the Azores. This past year, the Bermuda High went to Europe. There's been times when the Bermuda High has shifted and come all the way over to Nashville, Tennessee. Whenever it's not in its normal position, we affect the flow, the transport of moisture out of the Gulf, and that is what gives us the structure, the anatomy of a drought on the Mississippi Basin. This year when it's left, we watched parts of Canada burn on the east side, then watched the west side burn. There was wildfire smoke all across the country. It got very, very dry. The moisture shut off until it finally opened back up when the Bermuda High returned in late June. But the damage had been done. We started off the growing season with a drought monitor that looked something like this, where all of the drought was in the plains. And by the time we got into the middle of summer, that drought had moved its way to occupy most of the Missouri, parts of the Ohio, and most of the upper Mississippi Basin. That was what happened this year. Now, it then rained a lot in July and August, and that helped revive a lot of the crops in this particular area. But then late in the season, starting in mid-August and going to about September 19th, guess what? Bermuda High weakened again. And when it left, the whole of the Mississippi Basin got very, very dry again. And we watched the soil moisture values in late September, all the way down to 40 inches, be depleted by the crop. And this is modeled soil moisture values from NASA showing down here in the 2 percentile. Did it recover as we worked our way through September? No, it didn't. Only maybe up here in parts of this part of the Missouri Basin did it recover, but most of the Mississippi Basin got very, very dry. And with the latest data, the day I recorded this on October the 11th, we were still looking at substantial drought problems in the midsection of the country, even though there's some bigger rains forecast to come into this area. The problem is the subsurface soil moisture is still very, very low at this point. So why do I bring all of this up? Well, not only is this one of the world's big breadbaskets, but that river is not only key to getting all of the goods that are grown here out, but it's also important for bringing stuff back up the river through our barge traffic. And our biggest problem is this. Currently, the Mississippi River at Memphis is lower than it was a year ago at this time. Last year, the river bottomed out at about 11 feet below low stage. As of today, on the 11th of October, it is 11.48 feet below low stage. Now look at what this river did. It was way low last fall, it flooded in the spring, and there it is again, super low. This is what it looked like last fall. Here's a barge still trying to go down, but look at all the sand on this side of the river. This is near Memphis. And the video that's over here on the right, this is of a barge trying to still make its way through the river last fall, but got too close to the shore and actually went up on the shore and eventually broke apart because of this. This has already happened multiple times this year, and if you're curious, this is what the river looks like right now in St. Louis. In 2019, when that river flooded, where the person who took this picture is standing, she would have been under 20 feet of water. But this is how low the river currently is right there in St. Louis, and it's having a major impact on ag. So the big questions are these. This is what our current drought monitor looks like as of October 5th. That was the most recent update. We have 60% of the land area of the lower 48 in some form of drought. Are we going to see recovery this winter? Is this going to last in the next spring? These are some of the big water issues we're asking across parts of North America, because what I didn't detail is the drought that hit Canada this year as well. I didn't detail the drought that's in Argentina, the drought we're expecting to develop in parts of Australia because of certain factors in the Indian Ocean and the Pacific Ocean. So just a few things to think about here on World Food Day as we concentrate on how water resources are distributed across the world. Remember, water's conserved, so if some places going over dry, some other places going over very wet. And those are the kind of things I study every day as your senior science fellow. So just wanted to bring that to your attention. Thank you for your time today. We'll talk again soon. Thanks.